In this video, we are going to look at naming and coming up with formulas for binary ionic compounds, which would mean ionic compounds with one metal and one nonmetal. So remember that in an ionic compound, a metal will lose electrons, and that will go first. And an anion is a nonmetal that will gain an electron and go second when we write our chemical formulas. So metal is always first, nonmetal is always second, and we always follow that order with ionic compounds. Let's start right in with a problem, and we'll come back to these rules. So our cation is Na. A cation is a positive ion, and our anion is Cl. That's a negative ion. So what I would do next is go to my periodic table, and I think I'm going to grab a marker here so I can spotlight that a little bit. And I go up to my periodic table, and I'd feel so dumb if I can't find this. Oh, there it is, sodium, number 11 right here. And if I go up just a little bit, I have a charge on here that says +1. Remember, the alkali families want to lose an electron, giving them a plus charge 1, so it has an electron configuration like a noble gas. So Na is going to have a +1 charge. I'm going to sneak over here to chlorine, and that is a halogen, and that one needs to gain an electron to become like noble gas, but we can just look right above this family and see that that is -1. So let's go back and do this problem right here. So we retrieve that information from its position in the periodic table. I'm going to go to my draw function, and I'm just going to put the charge for sodium of +1. Okay, and the charge for chlorine of -1. Okay, now we try to do a chemical formula, and our charges have to balance. Well, if I have a +1 and a -1, that cancels out. So we're going to come up with the simplest ratio here and just call it NaCl. And that would be sodium chloride. A +1 and a -1 balance out exactly. So it is a balanced chemical formula. The name, I'll do the cation first, which is sodium. And I'll do the anion last, which is, I'm not going to dot the I, save you some time. And now the trick here is it's chlorine, but the INE ending gets changed to an IDE ending. CHLOR, instead of INE, it becomes IDE right here. So I guess that is the ID for NaCl, which is sodium chloride, or the identification is sodium chloride. Okay, so the metal, the nonmetal, changing the ene to an ide. Let's look at another one right here. We can take sodium, we know that that is +1, and we have phosphorus, which is a P. Let's go find that one. Whoops, I'll put a +1 right here. And I think I have to go to this to slide back and find phosphorus. I'm going to go to my periodic table, and I see P is over here. It's 1, 2, 3 away from a noble gas. It's going to need to gain 3 electrons. So that phosphorus is going to have a -3 charge. So I'm going to move back here, better line things in their position. Okay, that looks pretty good. And I'm going to change this to a plus, or I'm sorry, that's not a plus. That's a -3. So the metal is a plus, the minus is a 3. So looking at this, Na, might just write it down here, is going to have a +1 charge. put a +1 here. In the P has, which is phosphorus, has a -3. So what happens to balance charges, it's like if I lose $3, I got to win $1 3 times to balance it out. So I'm going to put a little subscript down here. And what this tells me is that 3 sodiums at +1, if I don't have a subscript, that would be 1. It balances 1 phosphorus at -3. Okay, so 3 sodiums at +1 balances 1 phosphorus at -3. I don't put the 1 in there usually. And that would be the balanced chemical formula, Na3P. You don't have to keep the charges in there, but sometimes it's just like showing your work. It's just nice to have that. Okay, and I don't think it's a problem if you leave them in because it's like showing your work. Okay, notice there's a switch, 1 and a 1 here, 3 and a -3 up here. So the digits here are the same, except this is negative. The digits here are the same, except I didn't put a 1 in there. Okay, I need to name this, and I'll do that by calling it sodium and this one's a little tricky. It's phosphorus, and you think it would be phosphoride. That would be my guess because it gets the INE ending. And to some, that sounds funny. So instead of saying phosphoride, we just say phosphide. Another common example of that, instead of saying like oxygen, we usually say oxide. So this one, the INE ending in, or I'm sorry, it's not an INE ending, it's phosphorus becomes phosphide. We get that IDE ending right there. So this would be sodium phosphide. The formula would be Na3P right here. Okay, let's just look at the other page because you're going to do this is page 5 of your homework packet. Want to look at page 6. I think I'm just going to erase this quickly or semi-quickly as we do that. And let's just look at a couple sample problems right here. Okay. All right, let's roll the screen, find a spotlight. Let's go to, sure I got a spotlight here. It's better. Okay, we're going to look at an example here. And I think I'd like to look at number 21. I got SrCl2. Okay, so when I'm naming, I'm going to name the positive ion first, which we know is a metal, which stays the same. And you might have to look at your periodic table, look up Sr. If you do, you'll find it is strontium. So I'll try to write that quickly. It's not going to be very quick. By the way, there will be a key that you can look at these things, and the key isn't super neat, but I think it's very readable if this is not. The next thing is I'm going to do chlorine becomes chloride. Oops, that wasn't supposed to carry. That's supposed to be IDE ending right here. So it's just strontium chloride, and I should have wrote this all in one space. Obviously, I don't have room to do that, but that would be the answer to number 1 right here, strontium chloride. Notice I don't have to say dichloride or anything. We could look up charges, and we would find out strontium is +2, chloride's -1, and because chloride has 1 less charge, I have to double it in order to balance things out. But when you name these, you just name them. Don't worry about saying di or tri or anything like that. We'll do that when we do naming of covalent bonded substances. Okay, here I'm going to do another one. And this one, I'm going to look up sodium, which I know is Na is +1. I'm not going to go to the periodic table just because I don't want to take time to do that. But if I look, iodide is a halogen. It's in the same family as chlorine was. So it does have a -1 charge. And again, the iodine becomes iodide. If I got a plus and a minus, is that balanced? Yes. So my formula is NaI. You don't really need these charges in there, but it's kind of like showing work. So if you keep them there, I don't have a problem with that. Let's look at number 26. That's a little bit trickier. Strontium is actually +2, so I'm going to accept that on faith. Okay, the faith of your chemistry teacher, but you can look it up, and that's +2. All right, and let's see. Phosphide, we did look that up before. We said that that was -3. Oh, this is a little tricky. So here we're going to do something. What's the smallest number that goes into 2 and 3? You're looking for the least common multiple, and that would be 6. So 3 goes here, 2 goes here. So if I have 3 plus 2s, I have +6. If I have 2 minus 3s, I have -6. So that balances. Notice the switch. This 3 and this 3 are the same, except this is a negative charge. This number 2 is the same as this, and this one has a positive charge. So that would be strontium phosphide. All right, that's pages 5 and 6. If you look on in the key, you'll find the notes for pages 3 and 4. You'll also find a lot of answers for pages 5 and 6. Good luck.